everyone. Today we're continuing our discussion of graphing parabolas. So I want to remind you our generic form of a parabola is y equals ax squared plus bx plus c. If you recall our last example yesterday, we had to kind of play with our table, as you can see over here to the right and up here, to find out the exact vertex. There is a better way of doing that, and that's what we're going to talk about today. So, symmetry and vertices. Parabolas have a geometric property called symmetry. That is, if the figure is folded in half, each half will match up exactly. The vertical line containing the fold is called the axis of symmetry. The axis of symmetry contains the minimum or maximum of the parabola. That's called the vertex. So the axis of symmetry for a parabola in the form y equals ax squared plus bx plus c, when a is in 0, is x equals negative b over 2a. And I rewrote that because the x equals kind of got wrapped around. That is our axis of symmetry. So in our example here, when we have y equals x squared plus 2x plus 5, we know that a equals 1, b equals 2, and not that we're using it right now, but c equals 5. So when we're finding our axis of symmetry, x equals negative b over 2a, we substitute those in. So it's negative 2 over 2 times 1, which equals negative 1. So our axis of symmetry is the line x equals negative 1. So our first example, consider the graph of y equals 2x squared plus 4x plus 1. First, we want to write the equation of the axis of symmetry. So to do that, we need to figure out that a is 2, because a is always the number in front of x squared. B is 4, because that's always the number in front of x. So we do x equals negative b over 2a. So x equals negative 4 over 2 times 2, which equals negative 1. So our axis of symmetry is x equals negative 1. Now to find the coordinates of the vertex, we take our original equation, y equals 2x squared plus 4x plus 1, because our vertex is always in the middle, and our vertex is always on the axis of symmetry. So in order to find the vertex, we take our x value from our axis of symmetry, and we're going to substitute it. We always substitute it in parentheses. So I substitute negative 1 for x into the equation, and then I calculate that. So that's 2 times positive 1, because negative 1 squared is positive 1, plus negative 4 plus 1. So that's 2 plus negative 4 plus 1, and that equals negative 1. So our vertex is negative 1 from over here, comma negative 1 from here. And in this case, that is a minimum because a is positive. So now let's do that again. So on number 4 down here, sorry about that. On number 4 down here, we want to consider the equation, determine whether it's a maximum or a minimum, state the maximum or minimum value, domain and range of the function, and find the equation of the axis of symmetry. So looking at that, a is 1, because a is always in front of x squared. There is no x, which means b equals 0. So since a is positive, it's a minimum. To find its value, I'm going to first find the axis of symmetry. So to do that, I do x equals negative b over 2a. So it's x equals negative 0 over 2 times 1. So the axis of symmetry is x equals 0. Again, I still need to determine the vertex, the value. So I'm going to substitute 0 into my equation for x. So the equation is y equals x squared plus 3 I substitute 0, so it's 0 squared plus 3. So that gives me 3. So the value of the minimum is 0, 3. That's my vertex. My domain is all real numbers. And my range starts at 3, so 3 is included, and goes up to infinity. To graph it, I want to use the table. So I can use my graphing calculator. So first I'm going to make it go by 1 again. So I'm going to hit plus in my table, make that say 1. Okay, so now I go to y equals, and I'm going to graph x squared plus 3. So x squared plus 3, make my table. And I want to see 0, 3 should be my middle point. So I'm going to plot -2, 7, -1, 4, 0, 3. And you can see the symmetry because you can see that it mirror images. So -2, 7. -1, 4. 0, 3. 1, 4, 2, 7. Connect with a smooth curve. And there is my problem. So I want you to pause, and I want you to do 5 and 6 and come back and check. So you can see that I graphed them. I made my tables. 4, 4, I knew that A was 1 because that's what's in front of x squared. B is 0. So my axis of symmetry is x equals 0. My minimum value, because A is positive, is 0, 3. Has a domain of -infinity to infinity, range of 3 to infinity. Now notice that the start of my range is the y value of the minimum point. Now I also want you to notice that when I graph my axis of symmetry, I can do it as a dotted line. It's always going to be a vertical line. It is the line that I could fold that parabola in half. So again, number 5, I made my table, plotted my points. A equals -1, B equals -4. Because A is -1, that tells me it's a maximum. That helped me find my axis of symmetry by substituting, and it became a -4 over 2 times -1. So when I did that, my axis of symmetry is x equals -2, which if I graph that again, it is the line that I could fold my parabola in half over. My domain is -infinity to infinity. My range goes from -infinity up to 0. And that's because it's a maximum. And notice the 0 is the y value in my vertex. Number 6, likewise, A is positive. It's 1, so it's a minimum. I found my axis of symmetry by doing -b over 2a. So it's -2 over 2 times 1, which is -1, which if I graph x equals -1, which is my axis of symmetry, that is the line I could fold that parabola on. I substituted that into y to find my vertex, which is -1, 2. My domain is -infinity to infinity, and the range is -2 to infinity. So that is the end of our video for today. If you have any questions, please ask them in class.